Hey, so it's week 2, and we're into basically the 4th lecture of Energy Y 241. I've got the textbook here, and I just want to thank Tim for kicking off the lectures. I'm not going to go into a whole heck of a lot today because I had some smartboard issues, but anyway, we're back up and rolling. I'm just going to give a couple little overviews. So the website is up and running. I'm just going to leave Brian Kearns there. He's the instructor who developed this course, and I know we're going to rely on him substantially throughout the semester. So I'm just going to leave credit where credit is due for Brian. But anyway, it is going to be a real pleasure for me to get to know the material in this course a little bit better. I have some background in chemistry. If I had to pick a top subject, it probably wouldn't be at the top. I was just invited to be a reviewer for some national testing, and I listed chemistry. But anyway, when I think about chemistry and do it, I do it in a very visual manner. I tend to think of the individual atoms and elements that make up different molecules, and as you know, all of these tie back to energy, and typically what we're doing in a fuels calculation or simulation or experiment, you're basically taking some type of hydrocarbon, and if you've taken the time to look through the syllabus, almost all of these fuels have a carbon atom somewhere. They've got a hydrogen atom somewhere, and sometimes you'll also see an oxygen atom. And of course, those are combining with atmospheric oxygen. When that happens, heat is released, and since you've all taken Energy Y 101, you realize that when a gas expands, you can then do work and drive a car or push a piston to make electricity, etc. So that's really at the foundation of what alternative fuels is about, and we're going to go through each fuel one by one. Before I get into today's lecture, though, what I'd like to do is just take a quick look at the syllabus. So here it is right at the top, syllabus NRG 24150, online course. And I've noticed that a couple students are already behind in turning in homework and submitting the first quiz. So let me just go over what the due dates are. Here we are, it's 9/8, and so what I'd like to do is make sure that everybody's posted something to the forum by the Wednesday of the week. So you don't have to post there's two lectures per week, one's on Tuesday, one's on Thursday. Post something by that Wednesday so we can read it. Gary just reminded me that I need to kick off the forum discussions. That's the way Brian Kearns has set it up. So I'm going to just dig into the forums here first, and then we'll take it from there. So again, these are the due dates. If you have not turned in the homework or finished the unit exam, please do that immediately. The second deadline for the homework is tomorrow, and then the second deadline for the exam is on Sunday. Okay, so I'm just going to hop into the introductions first. Oh, here we go. Introductions. I've got 5 unread posts. 4 replies. Let's just see who's replied. Okay, so I've got Gary there. I've got Jason. I've got Zach. Serenity is definitely here. I'm just waiting to hear from Curtis. So Curtis, are you out there? Okay, so we'll fire that out. There we go. Okay, so I think we're wrapped up with introductions. And basically here we are at week 2. And I'm just going to go ahead and kick this off. Okay. And to be honest, I'm not sure why this is called plastic fuel. Have you seen that anywhere else in the? Yeah.
Maybe it's a polymerase in the fuel. There's esters, I guess.
Well, there's a couple meanings for that. One meaning. So one meaning is it just could be that the input is variable, like a brain plasticity. It's changeable. Yeah, I don't think it's not plastic in the mechanical sense. But I think he just means plastics like HDPE, PETE. So that's one that I know about. The other thing that's worth noting is that plastics, so HDPE and LDPE in particular, if we just go and look those up very quickly, LDPE and HDPE. And again, we'll just take a look at the images. What you can very quickly discern is that low-density polyethylene and hey Wally, and high-density polyethylene, they're both just carbon and hydrogen. So when people express their concern for burning plastics, in particular HDPE and LDPE, you can say, well, compared to coal, which frequently has heavy metals in it, a lot of sulfurs. These plastics are very pure. I mean, they've already been highly refined, typically from an oil. The issue, though, at room temperature, these are solids. They're not liquids. Octane, which, you can look right in here, 1, 2, 3, 4, 5, 6, 7, 8. Octane, the only difference between HDPE and octane is that you've got an H sitting there and an H sitting there. It's a molecule that is has a discrete molecular weight. We'll get into molecular weights later. The molecular weight of HDPE can be huge. Thousands, if not millions, of kilodaltons. The main difference, though, between the HD and the LDPE is the microstructure. So you might have some unsaturated bonds where this particular carbon here or this particular carbon here, rather than bonding to 2 carbons and 2 hydrogens, it's actually bonding 3 carbons and a hydrogen, which changes the mechanical properties. And maybe we'll get in later into some of the production methods, but you can see that LDP is a variable temperature range for production, and HDP is at a higher temperature, and just lower atmosphere, and it's sitting there on a metal oxide as a catalyst or substrate. Okay. So that's week 2 discussion. Take a look at that. And I'm going to take a break, and then we'll get into a couple more things.